Welcome back to Master Tech, and in today's video, I'm going to show you how to use an awesome and powerful programming tool in the Python programming language called List Comprehensions. So if you've never seen list comprehensions in Python, or maybe you've seen them / heard of them, but you've kind of avoided learning about them because it seemed new and unnecessary, you're missing out, because this is an awesome feature that Python has available to you. And to show you a basic list comprehension, I'm going to use a pretty good example of some basic Python. All right, so let's say that I have a list and it comes in as all lowercase, kind of poorly formatted, and it's a list of names, in this case just 3 names. Well, the conventional way to write Python code to capitalize all of those names and then store them in another list or even the same list would be code that looks something like this. So it would be make a new list. In this case, we'd say like names underscore proper. And then for I in range of however many of those names there are. So if we added a 4th name, this code would not break. It would still be able to handle that. And then you might have some if conditional, maybe not. So in this case, just to show the power of list comprehensions, I added if names start with P. So in that case, I'm only going to grab names that start with P. So it would be Pete and Philip, but not Dale in this example. You don't need that step. Obviously, if you want to capitalize all of the names, you could just comment that out and skip it. But then you would do 2 things. You would capitalize each name, turn into a string transform called .title. This is a built-in Python function that parses a string and makes the first letter of each new word after a space a capital, and then store that in the list of proper names. And so if I run this, you'll see down in the bottom, I get all 3 names now capitalized and nicely formatted. And then to add back in the if conditional, let's say if we only want the ones that start with a P and I run it again, you'll see now I get the same list, still nicely formatted and capitalized, but just Pete and Philip, not Dale this time. And this code is perfectly valid and completely functional in Python, and probably something very familiar to people with a little bit of basic Python programming experience. But the incredibly powerful abilities of list comprehensions come in when we take a look at a way to define this all in one line. So the basic format of a list comprehension is up here in the comment. New list equals A for B in C if D, and if D is optional. But so what does this mean? Let's take a look at this example. So names proper is going to equal the actual value that we want, which would be each name turned into a title for, and then name, because this is just a variable that we're defining. Think of like an indexer variable that gets used in a for loop. So name.title for each name that is in the list names. And then we could stop right there, except that title needs those parentheses. We could stop right there, and to show you what that's going to do, it goes back to giving us all 3 of the original names and capitalized. But we can go even one step further. So this is where I said that if condition D is capitalized, or is optional, then what we could say after this too is if name dot, and then another built-in Python string function, which is dot starts with, and then starts with the letter P. So now this, if I run it, is going to give us just Pete and Philip, capitalized, nicely formatted. And so this is just one specific example. Obviously, there's not really a world where you would badly need to take a list of 3 names, capitalize them, and use a list comprehension. But this starts becoming incredibly powerful in much larger data sets and examples. And maybe the conventional Python programmer in you thinks like, well, this is a lot easier to read. You know, if you're not familiar with list comprehensions, this is a little bit of like syntax sugar, and it looks a little bit more difficult to read. Here I know exactly what's happening. Like I'm iterating through however long my names list is. I'm checking to see if it starts with a P, and if it is, I capitalize it using the title function, and then I add it to my names proper list. But once you learn to read a Python list comprehension, this line of code is doing the exact same thing. It is taking each item inside of this list, it is storing it in a variable called name, and then it is doing the .title transform to that variable, and then it's checking just like before to see if that variable, if that value starts with the letter P. So we have taken 5 lines of code here and turned them into 1 line of code. And strings and capitalizing things are kind of just the beginning of list comprehension. The use cases go all over the place. So that's kind of a good beginner example to introduce you to list comprehensions. Now let's take a look at a few different ways to do list comprehensions and a few different use cases. Okay, so I think a good second example to show you guys would be iterating through nested lists, also known as an array more correctly, or a matrix. And to show you how, let's say I have a matrix filled with lists, and I want to combine all of the components in those lists into one list. Now, typically in Python, if you do list concatenation, it will just add those together. But that's not always going to be what you actually want. And so it's still several lines of code and an if or for loop, something like that. And there's a really easy list comprehension for this. So let's say that I have this matrix with a bunch of lists in it. And, you know, obviously I've done the alphabet here, J, K, L, forgot the alphabet. That's embarrassing. M, J, K, L, M, N, O, P. You know, we'll leave it there. Good enough. Let's say that we want to create a list comprehension to store all of the values in those different lists in just one list going forward. And to do that, we'll say, okay, the ABCs are going to be equal to a character for each list in the matrix. But that's not really enough yet because we haven't defined where character is coming from. We want each character inside of each list in the matrix. And so what we do is we have this main loop, and we need to define a for loop after this main loop that's going to run in each iteration of the loop. So what we have to say is for character in each list. So I know that this is where list comprehensions start to look really gummy and really kind of goofy if you're not familiar with it, compared to just some nice plain for loops. And it's perfectly okay to go back to what you're comfortable with, but I also think it's very useful to acquaint yourself with these examples. What we are saying here, and the way to read this, is take every character for each list inside of the matrix for each character in that list. So I know the best way to kind of read this is sort of backwards, where we say take every character in each list for each list in the matrix. It's a little bit of getting your syntax figured out, but if we run this, you'll see, and I left all the code that we were using before in place, so at the end I can just dump this all in a GitHub for you. But what you can see there is we get one nicely formatted list at the end. And you could do things here like character dot upper if you wanted in all capitals dictionary list or anything like that. So you can still do the stuff that we figured out in the previous example of like string transforms or numerical transforms. But this is how you iterate through lists within a list, how you iterate through matrices and arrays that have lists inside of lists. You could theoretically have more for conditions after that, or you could have if conditions after that. So that's just another example showing the power of list comprehensions. Now I want to take a look at a few examples with numbers. This section of the tutorial will be called Fun with Numbers. No, it's not called anything. I don't do things that way. Okay, so let's say we want to make a quick list, and this is actually a list comprehension, but this isn't really the tutorial. Let's say we want a quick list of numbers, and this is just going to give us 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is basically saying for I in range 10, numbers dot append I. Okay, this is basically just getting us a list of numbers. Well, let's say I want to make a list of all of the squares, okay? I want to take each number and square it. This is the Python syntax for raising to a power. for num in numbers. Okay, so easy enough. If I print squares, then what you'll see, I spelled it wrong initially, squares. Then what you'll see when I run this is I get the numbers 0 through 9 squared though. Okay, so 0 squared is 0, 1 squared, 2, 3, 4, all the way up to 9 squared. Pretty cool. Obviously, you can do the same thing for cubes if you wanted. I know it's silly to call them squares, but now just by changing that 2 to a 3, we've got all these cubed values and things like that. So in a theoretical world where maybe this isn't 10 numbers, maybe this is 100 numbers, and maybe I want to know every cubed number that is divisible by if num cube 3 is divisible by, it doesn't matter, 6. Okay, so every cubed root that is divisible by 3, or divisible by 6 with no remainder. So to check for no remainder, I want to say modulo 6 is equal to 0, right? All right, so I know that was kind of a just pulled out of a hat example here, but this is going to go through and cube every value 0 to 99 and store it in a list if the cubed value is divisible by 6. And I, honest to goodness, have no idea which ones those will be. Okay. So there you go. There are apparently about 15 of those values. I couldn't actually tell you what these values are. I guess what we could do here, now it's just fun. Now we're just having fun, guys. Okay, so here I have added the number and what its cubed value is if it's perfectly divisible by 6. I don't know why this is such a surprise to me, but it is all the values that are a multiple of 6, which makes perfect sense, right? Because all cubing something is multiplying it by 6. But that was supposed to show you an example of cubed roots, and I can't stop laughing at myself for how silly an example that is. But hopefully you're still seeing the format of some value, and some value that can be manipulated or checked or even turned into a tuple, right? Like we took a number and we turned it into a tuple by saying we want to store both the number and its cubed value. So A for B, which is B is the one that's going to change the least because it's just the name of your indexing variable. And then in C, so whatever list we're checking through, if D, some condition to check against or check for, and that is a list comprehension. So I think the last thing I want to do in this tutorial is talk about kind of the natural extension of this, which is dictionary comprehensions. It's almost identical to list comprehensions, but there's a couple nuances about using list comprehension style checks against dictionaries. So let's take a look at just a few quick examples for those. Okay, so I'm going to run it all the way back here to kind of our first list, which was just 3 names, only now I'm going to make it a different list, and instead of a list, I'm actually going to make it a dictionary. So assuming you know a little bit about Python, a dictionary is obviously a bunch of keys and then their values. So dictionaries are organized into key value pairs separated by a colon, and then each pair is separated by a comma. So key, colon, value, and then a comma, and then the next key, colon, the next value, comma. Stored inside these curly brackets, that's what makes it a dictionary. If I want to transform this dictionary into a new dictionary, let's say adjusted salaries, okay, where I want to go through and I want to take all of the values that were in that first dictionary and I want to do something new to them, just like the list comprehensions. The format here is very similar. It's still A for B in C if D, only now you have to know about a couple little nuances, okay? So let's say I want to do 2 things. I want to do a full uppercase of the name. So I want to do name.upper, but then I also want to take a integer value of the salary to the nearest 1,000, okay? So let's say I want name.upper and then colon and then the salary. I want it to be an integer and I want to divide it by 1,000. Okay, so an integer salary divided by 1,000 for each name, comma salary in salaries dot items. Okay, so, and then you need these parentheses here. I'm trying to make sure my little camera square doesn't get in the way of the code. So what this is saying is take all of the items for each entry in salaries, split it into two variables called name and then salary, and then uppercase the name, and then take an integer divided by 1,000 of the salary, and then store that in a new dictionary. So if I print adjusted salaries, gosh, I hope this works. Run. Okay, what you'll see is you've got all three names fully uppercase. So this is different than .title, which we did in the earlier example up here. And then you have the integer value of their salary in thousands. Okay, so it's just a way of showing you can transform both the keys and the values inside of a dictionary using a dictionary comprehension at the same time. You just have to know this not tricky necessarily, but slightly new syntax until you get used to dictionary and list comprehensions. Just like before, you could say if salary greater than 100,000 if you wanted to, or if int of salary divided by 1,000 is greater than 100. It's basically the same check, just written in a different way. So this should only give us people whose salaries are above 100K, and it does. Pete drops off of there. And then you could add another thing that we haven't talked about yet. In list comprehensions and in dictionary comprehensions, you can combine if statements, and you can do this two different ways. So you can say if the salary is over 1,000 and if name dot starts with P. Okay, and so if you've been paying attention to our list, you know this will probably only return Philip. All right, and you can do that by saying if and then another if, or you can do it this way. You can say if, and then you can just like any other time, you can put two conditionals inside of inside of parentheses and use the keyword and. Okay, so this is a dictionary comprehension. This is also showing that you can combine if conditional statements. This is true for dictionaries and lists. And I think all of the examples combined in this video so far, I will drop this code if you want exactly these examples in a GitHub, and I'll leave a link to it in the description of this video, but you can probably cook up these examples or similar examples very quickly and easily yourself. There are so many use cases for list comprehensions and dictionary comprehensions. I'm sure there are probably things that I glossed over, things that possibly we missed, but I hope all in all this video was useful and taught you what you were looking for. If you have any questions, be sure to let me know about in the comments below. It was really nice to be able to just put together a Python tutorial, which is kind of how this channel got started. I've been diving into a lot of hardware and going all over the place lately, so it's nice to get back to the roots a little and do hopefully a useful Python tutorial for everybody. Be sure to let me know in the comments below what you'd like to see more of on the channel. Don't forget to leave a like on the video. Subscribe to the channel if you've been enjoying the content. Consider checking out my Patreon. There's a link below in the video as well. And as always, a massive thank you to my Patreon supporters, as well as everyone leaving likes and watching on LeMaster Tech YouTube. Good luck with your projects. Until next time, bye.